Okay, hi everybody. So today we're going to go ahead and start working through 20 through 28 of the Canary practice exam. So let's just jump right into it. Okay. So what is the sum of the series or series 1 plus ln of 2 plus ln of 2 squared all over 2 factorial and then so on all the way up? This one is actually pretty tricky because when we talk about the sum of a series, we've mentioned in class that there's really only two ways that we know how to do this, if it's geometric or if it's telescoping. This turns out to be neither one of these, or at least it doesn't look like either one of these. It kind of looks like geometric because you're multiplying by ln of 2 all the way up on the top. But the bottom is different because you have a factorial there. So you're not multiplying by the same thing every time along the way. So this is a little bit different. The key to doing this is to really knowing your Taylor expansions for sine, cosine, and e to the x. Okay, so which one does that mostly look like? You have something squared over 2 factorial, and I'm imagining it'd be something cubed over 3 factorial, and then so on. This looks very similar to e to the x. So we know e to the x is equal to 1 plus x squared all over 2 plus x cubed all over 3. Sorry, these are factorials. Plus all the way up to x at the end all over n factorial, and then it continues going on. Okay, so the only difference between this one and this one is that all the x's are ln of x's. So this is really e to the ln of x, which is equal to 1 plus ln of x plus ln of x squared all over 2 factorial and so on. Okay. But we have ln of 2, so you go ahead and put 2 in all those places, and you end up with this sum is equal to e ln of 2, which is simply just 2. Okay, so pretty tricky question. The answer there is 2. Okay, particle moves along a straight line. The graph of the particle's position, so this is x of t, this is the position graph. Okay, at time t is shown for 0 to 6. The graph has a horizontal tangents at t is equal to 1, t equals equal to 2, so that means there's a horizontal tangent line there and there. That means the derivative is equal to 0 there of the position. For what values of t is the velocity of the particle increasing? So velocity is increasing. That means I need to know the derivative of velocity. And the derivative of velocity, so v prime of t, is equal to the second derivative of position, if we use x to represent position. So I need to know what the second derivative of this is. And when the second derivative is positive, that means velocity is increasing. When the second derivative is negative, it means it's decreasing. So if you take a look at this, this is really just asking what's the concavity of x of t. So the graph here is going to be concave up, concave up, concave up, and then it switches the concave down. So really, it's only going to be from 0 to somewhere around there that it stays concave up. And the only place that matches up there is going to be A. Okay. 22. Okay, the graph. The table above gives the values of f prime g, and g prime for the selected values of x. If the integral from 0 to 1 of f prime of x gx dx equal to 5, then what is this? Okay, so if you take a look closely here, I need to somehow be able to go, let me zoom in a little bit. I need to somehow be able to go from f prime, or actually I want to go from here to extract this. So I need to change f of x to f prime of x and g prime of x to g of x. Well, we do know how to do this. This is integration by parts. Okay, so this is where we're going to go u dv. Actually, yeah, I guess we can do it that way. V and then du. So here I am, I want to integrate this. And when I go from there to there, I want to change f into f prime. That means I need to take the derivative of it. So what that means is my u is going to be f of x, and then du is f prime of x dx. That means my v, actually my dv, is going to be g prime of x dx, and then therefore v is g of x. Okay, so now we just integrate this using integration by parts. So uv, so I have f of x, g of x, minus the integral of v du. So v is g of x, and du is f prime of x dx. And we have to evaluate these from 0 to 1. So this is going to be equal to f of 1 g of 1 minus the integral of g of x f prime of x. Oh, look, I have that. That's just 5. So this is equal to f of 1. Go up to the table up above here. So f of 1 is going to give me 4 times g of 1. So g of 1 is going to give me 3 minus 5. So you have 12 minus 5, and that's going to give you 7. Sorry, I just want to double check my work here and make sure I'm doing it correctly. Oh, yeah. I didn't do that right, did I? You see what I did wrong? Okay, it's right here. I did f of 1, g of 1, but then it should have been minus. I have to plug in the bottom limit. F of 0, g of 0. I apologize. And then we have minus 5. Okay, so I still need to take this away. So this would be minus f of 0, g of 0. So 7 minus f of 0. F of 0 is 2. G of 0 is negative 4. So you have 7 plus 8 is going to give me 15, which is the correct answer. Okay, it wasn't 7 from before. So 15. Okay? Sorry about that. Okay, so next one. If f of x is equal to x sine of 2x, which of the following is the Taylor series for this? So I need to start with sine of x. So I know sine is the odd function. So sine of x is equal to x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial, and then so on. So if I have sine of 2x, I just plug a 2x in everywhere there's an x. This is going to be 2x minus 2x cubed. So this is 8x cubed over 3 factorial plus 2 to the 5th, it's a 5, is 32. Now of x to the 5th power all over 5 factorial. And then minus, so 2 to the 7th is 128. X is 7th all over 7 factorial. And then all I have to do is multiply by x up here. I'm going to take this, multiply by x, and I have x times sine of 2x is equal to 2x squared. So I know I'm down to d or e, minus 8x to the 4th all over 3 factorial. So you can see here my answer is going to be e. Okay, next question. Seem to have lost my papers. Here we are, 24. Okay, so this is a logistic graph right here. It says, which of the following differential equations for population P could model the logistics growth figure are shown in the figure above? So we know that the equation for this is going to be A is equal to some K value times P times 1 minus P all over whatever the carrying capacity is. In this case, we know the carrying capacity is 200, so it should look like that. So all I'm going to do is focus on which one of these is going to give me 200 when I write it in that form. Okay. So the top one, actually, I'll start at the bottom one here. So I'm going to factor out what I can, and I want to change this. So I need the P there. So I'm going to factor out P. So I'm going to factor out this to turn it into 1. So this is going to be 0.001 P. And when I do this, this is going to give me 0.1 P squared, actually P, all over 0.001. Okay, and then plus 1. Okay, so then I just have to figure, okay, well, what is this going to be equal to? So 0.1 over 0.001. So 0.1 is 1/10. 0.001 is going to end up being 1 over 1,000. So if you flip and multiply, this is going to give you 100, and even the 100 is on top, so this is not going to work. Okay, same idea here. I'm going to factor this out of this, and so I'm only going to take 0.1 divided by that. Oh, I get the same thing. This will also not work. Okay, go ahead and try this one now. I'm going to factor this out of this. So I'm going to have 0.2 divided by 0.001, which is 2/10 all over 1 all over 1,000, which gives you 2 times 1,000 all over 10. And once again, that's not going to work because it needs to be 1 over 200. Okay, so this one. So now notice that they did flip this around now. So now I'm going to factor out the 0.1. I'm going to divide it out of this. So I'm going to take 0.001 and divide it by 0.1. And so this is going to be 1/1000th divided by 1/10, which is going to give me 1/100th. That's not what I'm looking for because I want it to be 200. So this one, once again, now I'm going to take out the 0.2, so I'm going to divide it out of this. So I 0.001 divided by 2, which is 1 over 1,000 divided by 2 over 10, which is going to give me 1 over 200. Okay, so A is going to be my answer. Okay, 25. Let f be a differentiable or be a function defined above, where c and d are constants. If f is differentiable at 2, then what is the value of c plus d? Well, if it's differentiable, let's go ahead and evaluate what it would be. So f prime of x is going to be equal to, so the derivative of this just gives you c, and this one x is less than or equal to 2. Then this will be 2x minus c, and that's when x is greater than 2. Okay, so if it's differentiable at that spot, it means it should be equal to it at the same location. So I wouldn't normally do this on a multiple choice because this is all about speed, but I do want to show you the proper way to do this. Okay, so what we want to know is we want to show that C is going to be equal to, and I'm going to leave a blank here and you'll see why in a second, 2x minus C. But the problem is you can't just set those equal to each other because this will actually never be equal to 2. But instead, if you remember, we're talking about the limits as it goes to this. So we're actually going to take the limit as x goes to 2, and it's going to be from a side, which we'll decide in a second. And you have the limit as x goes to 2 from the other side. Okay, so this is when x is less than or equal to 2. That means it's going to be approaching it from the negative side. So this is negative, and this is when x is greater than 2, so it's approaching from the positive side. So that'd be positive. Okay, well, this is just equal to 2. Actually, no, it's just equal to c because I don't know what c is. Is equal to, now here you're going to plug it in, and you have 4 minus c. So you have 2c is equal to 4. C turns out to be equal to 2. Okay, now that's only 1/2 of what I needed. I need to actually figure out what the other part is. Now, if it's differentiable at 2, it's also continuous at 2. Remember, differentiability implies continuity, but continuity does not imply differentiability. Okay, so I know it's differentiable, therefore it's continuous. So I have to attack it from the same notion, but using these equations. So I have the limit as x approaches 2 from the negative direction of cx plus d should be equal to the limit as x goes to 2 from the positive direction of x squared minus cx. Okay, now what I was saying earlier about like if this is a multiple choice question, I wouldn't write these limits. I would just know to plug them in. Okay, but if it's an FRQ, you definitely have to write that. Okay, so C I know is 2. So and then I'm going to plug in what this is equal to. So I have 2 times 2 plus D is going to be equal to 2 squared minus 2 times 2. So I have 4 plus D is equal to 4 minus 4, which is 0. So D turns out to be negative 4. I'm looking for C plus D. So negative 4 plus 2 gives me negative 2. Okay, next question. Okay, so which of the following expressions gives the total area enclosed by the polar curve? That in the figure below. So you know the formula for the area of a polar curve is 1/2 the integral from A to B of r squared d theta. R is that, so the area is going to be 1/2 the integral from A to B of sine to the 4th theta d theta. So my answer has to be one of these 3. By the way, as a trick, when you're solving multiple choice questions, if you have no idea, typically you want to go to the one that has the most things in common. Okay, so you would probably exclude those, and you notice you would go right to there and take a guess out of those. Okay, so now I need to determine what limits are. So the first thing I need to do is I need to determine when the graph is going to go through the pole. Okay, when is it actually going to go through the pole? So I'm going to take that equation right there. I'm going to set it equal to 0 because that's when the radius would be equal to 0. So if 0 is equal to sine squared theta, 0 is equal to sine of theta. So you know theta is going to be equal to 0 and at pi. Okay, so it's going to start here and it'll rotate up until it gets to there. So the area of this would be from 0 to pi. So, but I want all of the area. So I'm just going to integrate from 0 to pi and then double it. So this is equal to 2 times a half times the integral from 0 to pi of sine to the 4th power of theta d theta. So the answer there is going to be D. Okay, next question, 27. Which of the following could be the slope field for the differential equation, okay? So typically speaking, how I do this one is I start off by saying, okay, what will make it equal to 0? So you notice if y is equal to plus or minus 1, then dy dx is going to be equal to 0. So I'm just going to go to these graphs and figure out, I'm going to look at 1 and negative 1 and determine if that slope is equal to 0. So 1 looks like it's about right there. And if you notice, it does look like the slope is honing in on 0 there. Negative 1 is going to be down there, and it also looks like it's honing in on 0 there. Okay? This will never, well, not never, it will not uniformly be equal to 0. And this uniformly won't be equal to 0. Not, and not. So my answer has to be A. Okay. There's lots of different ways of doing this, but typically speaking, how I start off is I go right away and I take a look where the derivative is equal to 0. Okay. Last page, number 28. Okay, so in the plane, a particle moves along the parabola y is equal to x squared minus x with a constant speed of 2 rad 10 units per second. If dx dt is greater than 0, then what's the value of dy dt when the particle is at the point 2, 2? So you should definitely notice that that this is going to be parametric. Okay, but there aren't any parametric equations, but I can parameterize it on my own. So remember, trick to parameterize in this usually is saying, okay, let's let x equal to t, and then therefore y is equal to t squared minus t. Okay, now it does give me what the speed is. And by the way, this parameterization is not unique. Okay, there's a whole bunch of, you can do this infinite different ways. Okay, so, and then I should go back and, so the key here is this may or may not be the correct parameterization of this graph based off of what the speed is going to be. So I'm going to start here and I'm going to work forward to see if it works. So if you remember, the speed equation is the square roots of x prime of t squared plus y prime of t squared as well. Okay, so if this is x and this is y, then I have dx dt is equal to 1, and dy dt turns out to be 2t minus 1. So I'm going to go plug those into the equation. I should have 2 root 10 is equal to the square root of x prime squared, so that's just 1, plus y prime squared, which is 2t minus 1 squared. Now, according to the parameterization that I have right here, I want to figure out what the value of t is. That's going to put me at the point 2, 2, because that's where I'm evaluating. Well, clearly you can see here, t is equal to 2. Okay, so going over here, plug into this equation, I have 2 root 10 is equal to the square root of 1 plus 4 minus 1 gives me 3 squared. So 2 root 10 is equal to root 10. Hey, that doesn't work out. That's not a true statement. So what that means is that this parameterization is wrong. I have to come up with another one. Okay, so let me try something a little different. I'm going to let x equal to 2t. So in doing so, I'm going to have y is equal to, plug into this equation. So 2t squared is going to give me 4t squared minus 2t. Now you notice when t is equal to 1, it's going to put me at the point 2, 2 like before. Okay, so let's see if this works. And by the way, well, let's go through this. Let's see if this works. So once again, speed is equal to the square root of x prime squared plus y prime squared. So I have 2 root 10 is equal to, so I have to figure out x prime is. So x prime is 2, and y prime is 8t minus 2. So this is going to be 2 squared, which is 4, plus 8t minus 2 squared. Okay, once again, at this point, t is equal to 1, so plugging it in, I have 4 plus, so this will be 1. So 8 minus 1, or sorry, 8 minus 2 gives you 6, 6 squared gives you 36. So 2 root 10 is equal to the square root of 40. If you factor out a 4 here and then take the square root of it, you get 2 root 10. So this does work. So this is the correct parameterization here. And I need to figure out what dy dt is, or y prime. So y prime is right here when t is equal to 1. So y prime of 1 is equal to 8 minus 2, which gives me 6. So the answer should be 6. Okay, so that's it for part A. We'll get going on part 2 tomorrow. Thanks, everybody.